Before a single brick is laid, a construction site is just a chaotic pile of raw materials. To turn that heavy, loose rubble into a precise, load-bearing structure requires a strict adherence to procedure. At their core, walls serve two distinct purposes. They safely support the tremendous downward weight of a building, and they divide open areas into organized, usable interior spaces. To determine exactly how a wall should be built, we can use a simple memory tip from this guide, LNEP. That stands for load-bearing walls, non-load-bearing walls dividing space, exterior walls facing the weather, and partition walls separating rooms. Getting these structures wrong carries high stakes. As the document highlights here, common mistakes like crooked walls, uneven mortar, and poor bonding will leave a wall weak or visually ugly. To avoid those failures, professional builds follow strict safety rules. Looking at these guidelines, success requires selecting good materials, continuously verifying straight measurements, and using proper tools right from the start. Identifying exactly which of those 4 LNEP wall types you are building will dictate every technical decision, tool choice, and material standard used throughout the project. The physical construction process begins on the ground. Builders start by marking out the exact wall position, often by snapping a chalk line across the foundation slab to establish a perfectly straight base. Skipping this measurement or rushing the foundation prep locks in structural errors immediately. A base that is off by just a fraction of an inch guarantees a crooked wall that cannot be corrected in the higher layers. Next comes the mortar. Builders mix sand, cement, and water until they achieve a very specific chemical consistency. It must be thick enough to hold the immense weight of the blocks, but fluid enough to spread evenly across the surface. This procedures list shows the chronological order for that first course. After you mark out the position and prepare the foundation, you mix the mortar and finally lay those first blocks or bricks firmly into place. If the mortar is spread unevenly beneath those first blocks, it creates tiny air pockets and pressure points. Under thousands of pounds of downward force, those uneven weak points can cause the bricks to crack. That first row of blocks must be perfect. It acts as the geometric blueprint, setting the exact level and alignment for every single layer that will be built on top of it. Once the base is set, builders focus on bonding. As defined in this guide, bonding is the specific pattern used to arrange the blocks as the wall grows taller. Two common patterns are the stretcher bond, laid lengthwise, and the header bond, turned widthwise. In both, vertical joints are staggered. When weight presses down, these seams disperse the load horizontally, stopping vertical cracks from traveling straight down. With the pattern established, builders continue stacking layer by layer. On every single course, they use a spirit level to check that the top edge remains perfectly horizontal and the face of the wall remains vertically straight. Checking our standards section here, we can verify the physical markers of a high-quality build. The final structure should feature perfectly even joints, absolutely no cracks, and a strong, stable presence. Structural integrity isn't an accident. It is achieved by combining these exact bonding patterns with relentless geometric checks at every vertical step. A completed brick structure is strong, but it is still vulnerable. Finishing is the process of applying specialized coats to make the wall smooth, visually neat, and protected from environmental damage. For exterior walls, this document defines a process called rendering. Builders apply a thick, rough coat of mortar directly to the outside face, which shields the structure from harsh sun, driving rain, and wind. On the inside of the house, walls undergo plastering. This involves applying a much finer, smooth coat of material to the interior brickwork, prepping the surface so it is entirely flat and ready for paint. When builders need to flatten massive floor areas or particularly rough wall surfaces, they use a technique called screeding, smoothing out specialized mortar to create a perfectly flat plane. Finally, the aesthetic layers are applied. While standard bedroom walls receive paint to improve appearance, kitchens and bathrooms require tiling. As listed here, tiles provide a necessary water-resistant barrier that is easy to wipe clean. Finishing is the necessary final step. It guarantees the raw strength built in the underlying layers remains durable, protected, and practical for daily living. What began as a loose pile of dust and rough materials is now a fully realized architectural feature. By utilizing the LNEP framework, builders know immediately if they are assembling a load-bearing, non-load, exterior, or partition wall, allowing them to match their materials to the structural demand. Reviewing the final summary of our guide, we can verify the standards. A proper wall utilizes precise bonding for strength, sits perfectly straight and level, and features clean, unbroken joints without a single crack. Skipping the finishing layers might save time, but it leaves that precision brickwork completely exposed to the elements, guaranteeing rapid decay. When you respect the guidelines, verify your measurements on every layer, and properly seal the exterior, the result is a wall that is strong, safe, and built to last.